June 15, 1940, Hornchurch, England. The air smelled of gasoline and dust. Two Spitfires stood side by side. Same engines, same pilots, same war ahead. But when the signal came, one took off in 320 yards, and the other soared after only 225. No one could explain it at first. The difference wasn't the engine or the pilot. It was the propeller. Three thin blades, once called too complicated, had just changed the future of flight. In a war where every second meant life or death, one engineer's impossible idea made American and British fighters up to 100 miles per hour faster. And it changed the sky forever. Stay with us to see how one man's invention turned doubt into dominance. Don't forget to subscribe, like, and watch till the end. This is the untold story of the propeller that won the war. June 15, 1940. Hornchurch Airfield, Essex. The morning sun burned through thin mist, glinting off the silver skin of two parked Spitfires. The smell of fuel and hot rubber hung in the air. Ground crews stood ready, stopwatches in hand. Both planes looked identical. Same wings, same powerful Merlin engine, same pilot climbing into the cockpit. The only difference was the propeller. The first Spitfire roared forward. Its tires screeched, its tail lifted, and after 320 yards it climbed into the sky. The second lined up right after. When the pilot opened the throttle, the propeller blades shifted their angle, like a bird adjusting its feathers. The plane rose in just 225 yards. It reached 15,000 feet, almost 4 minutes faster. Pilots watching from the ground couldn't believe it. Same plane, same engine. How? One of them muttered. The answer wasn't more power. It was control. The new propeller changed its own blade angle to match the air, keeping the engine at its best speed all the time. It was almost like it could think. This was the paradox. Something so simple, three blades turning through the air, made aircraft 100 miles per hour faster and gave pilots a new kind of control in combat. Frank W. Caldwell, the man behind this idea, wasn't at Hornchurch that day. He was thousands of miles away in Connecticut, working quietly in a small factory office. But what happened on that airfield was the living proof of his impossible dream. A propeller that adjusted itself mid-flight. What began as one man's theory had become a weapon that could decide life or death. And for Caldwell, it had started 8 years earlier, with a noisy wooden test rig, a small team of tired engineers, and a problem the world thought could never be solved. But before the miracle of Hornchurch, there was only the hum of an experimental motor, and a young engineer who refused to give up on an idea everyone else called crazy. In 1932, in a small workshop at Hamilton Standard in Connecticut, a young engineer named Frank W. Caldwell was working late again. The place smelled of machine oil and hot metal. The air buzzed with the sound of grinding tools. On his desk sat a strange-looking propeller, part wood, part aluminum, connected to wires, pumps, and a noisy test motor. Caldwell was not a famous man then. He was quiet, careful, and obsessed with one question. Could a propeller change its own shape while flying? Most people said no. Airplanes used fixed-pitch propellers. Their blades stayed at one angle all the time. It worked fine for takeoff or landing, but not both. A pilot had to choose between climbing fast or flying fast. Caldwell believed he could fix that. He imagined a constant speed propeller, one that automatically changed the blade angle as the plane's speed and air pressure changed. It would be like a car shifting gears by itself. He tested idea after idea, and each time something broke, the gears jammed, the oil leaked, or the propeller tore itself apart. His co-workers laughed gently. "Frank," one of them said, "you're chasing ghosts." Even his bosses thought it was too complex, too heavy, too dangerous for pilots to trust. But Caldwell wrote in his notebook, "If the propeller can't adapt, the plane can't improve." One freezing night, he stayed after everyone left. The heater rattled in the corner while he adjusted a tiny hydraulic valve with a wrench. He started the test motor again. The propeller spun faster, whining louder, then click. The blade slowly turned, changing pitch smoothly for the first time. Caldwell's eyes widened. It worked. Weeks later, he invited his supervisor to watch. The test stand shook, the propeller spun, and when the blades shifted automatically, the older man nodded slowly. "You might have something here." By the end of the year, Hamilton Standard filed a patent for a new design, a hydromatic constant-speed propeller. It used oil pressure and a small governor to control blade angle automatically. But even then, the world wasn't convinced. The U.S. Army Air Corps had no money for unproven gadgets. Airlines didn't want the risk. The only way to prove it would work was to test it on a real airplane. And that chance came suddenly. In February 1933, when a Boeing 247 airliner nearly crashed high over the Rocky Mountains. The test that followed in Denver would change everything and turn Caldwell's quiet invention into a symbol of survival. February 15, 1933, Denver, Colorado. The air was thin and cold, biting at the faces of two Boeing test pilots as they taxied their shiny new 247 airliner down the runway. It was supposed to be the fastest passenger plane in America, a twin-engine wonder built to fly over the Rocky Mountains with ease. But that morning, it struggled. At full power, the plane climbed too slowly. One of the engines ran too hot. The other lost power when the pilot reduced throttle. At 10,000 feet, the airplane shuddered in the wind. The fixed-pitch propellers could not keep the engines in their best range. The pilots returned to the airfield shaken and angry. The airline's chief engineer called Hamilton Standard that same day. His message was simple. Either you fix this, or we'll buy from someone else. So they called in Caldwell. He arrived in Denver 2 days later, carrying his notebook and a small metal device wrapped in cloth, his experimental constant-speed propeller hub. The hangar smelled of cold oil and dust. Mechanics gathered around as Caldwell showed his idea. This propeller changes its own pitch, he said softly. It keeps the engine at the perfect speed, no matter what. Most of the men frowned. One pilot whispered, "If that thing fails, we're dead." But Caldwell insisted on a test flight. They fitted one engine with his propeller and left the other as it was. A perfect side-by-side comparison. The next morning, the Boeing lifted off again. From the ground, engineers watched the altimeter needle climb. The engine with Caldwell's propeller ran smoothly, holding steady RPMs. The other struggled, coughing as the plane rose through thin air. When the plane landed, the results were clear. The constant speed side had climbed 40% faster and burned less fuel. One pilot said, "That's not a propeller, that's a brain." Within weeks, Hamilton Standard received letters from the U.S. Army Air Corps and Pan American Airways asking for demonstrations. Caldwell had done what everyone said was impossible. He had built a propeller that could think. Later that year, the National Aeronautic Association awarded him the Collier Trophy, America's highest aviation honor. President Franklin D. Roosevelt himself congratulated him, saying his invention would advance the art of flight. But even after this success, many in the aircraft industry still doubted him. Some called it too expensive. Others said pilots wouldn't trust an automatic system. Caldwell didn't argue. He just smiled and said, "The sky will prove it." He was right, but proof would not come in peace. It would come in war. As Europe slid toward conflict, engineers and generals would soon discover that Caldwell's strange invention was not a luxury. It was survival itself. By the late 1930s, dark clouds gathered over Europe. Factories worked day and night, and nations rushed to build faster, stronger airplanes. But even as engines grew more powerful, propellers still held them back. At Wright Field in Ohio, American engineers tested new fighters and bombers. Some had 1,000 horsepower engines, but their old fixed-pitch propellers wasted much of that power. One pilot joked, "We've got racehorse engines pulling plow blades." Caldwell knew he could fix that. His hydromatic propeller could adjust its own blades automatically, keeping the engine at the best speed for climbing, cruising, or diving. It was smooth, safe, and powerful. But not everyone believed him. At an air show in 1938, Charles Lindbergh himself asked, "Can it really work in combat? What happens if the hydraulics fail?" Others worried the system would be too heavy or too complex for frontline aircraft. Some even said pilots wouldn't understand it. Caldwell didn't argue. Instead, he showed them numbers. In one test, a P-26 fighter climbed from 5,000 to 20,000 feet, 2 minutes faster using his propeller. Top speed rose from 187 to 203 miles per hour. Fuel use dropped by nearly 15%. Even the skeptics began to listen. One officer from the Army Air Corps said, "If these figures are true, this thing could win wars." But time was running out. In September 1939, Germany invaded Poland. Within months, Europe was burning. Britain stood alone against the Luftwaffe. At RAF bases like Hornchurch and Biggin Hill, Spitfires fought daily against German Messerschmitts. Pilots complained that their planes lost speed during climbs and that the engines sometimes over-revved or failed when diving. The old two-position propellers couldn't keep up with fast-changing air combat. British engineers tested several fixes, but nothing worked well. Then, through a desperate supply deal, they reached out to Hamilton Standard. Caldwell's design, already licensed by Rotol in Britain, became their last hope. In June 1940, the first constant-speed propeller arrived in England. Mechanics at Hornchurch replaced old propellers on 12 Spitfires in 72 hours. On June 15th, they tested the results, the same demonstration that opened this story. The numbers shocked everyone. Planes took off in shorter distances, climbed faster, and reached 7,000 feet higher than before. Air Chief Marshal Hugh Dowding immediately ordered mass conversion across fighter command. By September 1940, during the Battle of Britain, over 90% of RAF fighters had constant speed propellers. The results were clear: faster climbs, better fuel use, and fewer engine failures. Pilots wrote home saying the new props felt alive, like the plane was finally flying the way it always should. The invention that began in a small workshop had become a weapon of survival. But while Britain fought in the skies, America's factories were preparing for their own storm, a race to produce thousands of these life-saving propellers before war reached them too. In 1941, months before America entered the war, the Hamilton Standard Factory in East Hartford, Connecticut, was already running day and night. The smell of oil and metal filled the air. Sparks flashed as workers shaped thousands of propeller blades. Most of them were young, men too old to fight, and women new to factory life. Frank Caldwell walked through the factory floor each morning, clipboard in hand. He checked every test rig himself. His invention, once built by a few men in a small workshop, was now the heart of a massive war machine. The U.S. Army, Air Corps, and Navy ordered propellers for every type of aircraft, from small trainers to giant bombers. Production grew so fast that the company had to hire over 20,000 workers. By 1943, Hamilton Standard was making 12,000 propeller assemblies each month. Still, most people didn't understand how it worked. So pilots explained it simply: it's like shifting gears in a car, but the propeller does it for you. Inside the hub, oil pressure and a small device called a governor constantly adjusted the blade angle. When a plane climbed, the blades turned to low pitch for more thrust. When it cruised, they shifted to high pitch to save fuel. In an emergency, they could feather, turning edge on to the wind to stop a dead engine from dragging the plane down. One bomber pilot later said, "Feathering saved my crew more than once. It turned panic into control." This system gave American pilots a new kind of confidence. Their engines ran smoother and lasted longer. Fighters like the P-47 Thunderbolt and P-51 Mustang used the hydromatic propeller to reach speeds over 430 miles per hour, nearly 100 megatonnes faster than older models using fixed-pitch blades. But even as Caldwell's design spread across the Allied air forces, he worried. The speed of production left little room for error. Every propeller had to work perfectly, or lives would be lost. And soon, that fear came true. In 1943, news came from England. A B-17 bomber named Hell's Angels had crashed after takeoff. Witnesses said one propeller failed to feather properly. The plane spun out of control, killing all 9 crew members. The cause was traced to hydraulic contamination, a small flaw made deadly by mass production. Caldwell took it personally. Every drop of oil, every seal, every valve matters, he told his engineers. He ordered stricter inspections, better materials, and redesigned seals. Within months, failure rates dropped to near zero. Factories slowed just enough to ensure quality. It was a painful lesson. Even a miracle needed discipline. By 1944, those lessons would pay off. With every perfect propeller leaving the line, the Allies were ready to fight and win the air war over Europe. By early 1944, the skies over Europe were filled with the roar of engines. American bombers flew in long silver lines, guarded by fast fighters like the P-51 Mustang. These aircraft now used Frank Caldwell's constant speed propellers, and it changed everything. Pilots noticed the difference right away. Lieutenant Jack Reynolds of the 8th Air Force wrote in his diary, "The new prop makes the plane climb like it's alive. You pull back and it just goes." Before, escort fighters had to turn back halfway to Germany to save fuel. Now, with better efficiency from the hydromatic propeller, they could stay with the bombers all the way to Berlin and back. That meant fewer bombers were lost, and fewer families received the dreaded telegrams. The numbers told the story. A P-51 with Caldwell's propeller could reach 437 miles per hour and climb over 41,000 feet. German pilots flying Messerschmitt Bf-109s simply couldn't match that. American commanders said the single invention helped cut bomber losses by nearly 30% in late 1944. The technology spread fast. Every major Allied aircraft, from the B-17 Flying Fortress to the C-47 Dakota Transport, used some version of Caldwell's design. Even British and Canadian factories licensed it, producing hundreds of thousands of blades each month. Pilots didn't see math or hydraulics when they looked at their spinning blades. They saw trust. One RAF pilot said, "That propeller knows more about flying than I do." In combat, that trust meant survival. When a bomber lost an engine, the crew could feather the propeller and keep flying. There were hundreds of stories of crippled planes limping home on 2 or even 1 good engine, all because the propellers worked perfectly. But behind the glory, the factories kept pushing. Workers stood at lathes and drills for 12-hour shifts. The constant hammering of metal echoed day and night. One worker remembered, "Your hands smelled like oil for weeks, but you knew every bolt you tightened might save someone's life." Caldwell rarely slept. He reviewed test data, field reports, and letters from pilots. Some thanked him personally. Others described failures he needed to fix. He replied to almost everyone. The paradox was clear. His invention was simple in purpose, just to turn air into motion, yet it carried the weight of thousands of lives. By summer 1944, the Allies had full control of the skies over Western Europe. Air superiority meant the D-Day invasion could succeed. Engineers at Hamilton Standard listened to radio reports of Normandy landings while machines still ran in the background. One mechanic said quietly, "Those blades are over France right now." But even as victory neared, Caldwell's story wasn't over. The end of the war would reveal just how deeply his impossible idea had changed aviation forever. When the war ended in 1945, the world took a deep breath. Cities were in ruins, soldiers were going home, and factories began to fall silent. But one man, Frank Caldwell, was still working. He wasn't done yet. Caldwell knew that his constant speed propeller had helped win the air war, but he also saw something new rising: jet engines. They didn't need propellers at all. It became clear that his impossible idea had quietly built the bridge between 2 ages of flight, from propeller to jet. There was a quiet beauty in it. The very machine that once carried bombs now carried medicine and mail. The same spinning blades that had roared over Europe now turned slowly above fields and farms. It was another paradox, a weapon of war becoming a tool of peace. Caldwell continued to work until the early 1950s before retiring. He didn't seek fame, and most people never knew his name. But pilots, engineers, and mechanics did. One of them said, "Every time that prop spins, a piece of him spins with it." And yet the real impact of Caldwell's invention would not be measured in medals or miles, but in how it changed what people believed was possible. By the 1950s, airplanes were changing faster than ever. Jet engines ruled the skies and propellers slowly became part of the past. But even as the world looked forward, engineers still studied has increased the efficiency and safety of every powered aircraft. At the ceremony, a general who had flown bombers in the war told him, "Your invention gave us speed when we needed it most. We owe you miles of sky." Still, Caldwell stayed humble. He didn't see himself as a hero. He once said, "I just solved a problem. The real heroes were the ones who used it." In the years after the war, his propeller designs were used in new ways for firefighting aircraft, crop dusters, and mail planes. Standard for almost every propeller aircraft in the world. From small Cessnas to giant airliners, all of them used some version of his design. His propeller even flew into space on test aircraft during early NASA experiments. The paradox was complete. A man who once struggled to make a simple mechanism spin at the right speed had helped humanity reach the edge of the atmosphere. But Caldwell never called himself a genius. When a reporter asked him what drove him, he answered quietly, "Curiosity. I just wanted to make something that worked better." In history books, his name appears beside words like efficiency, innovation, and persistence. But in the memories of those who flew his machines, it meant something simpler: trust. He proved that even in the middle of a brutal war, invention could be an act of hope. He turned a humble piece of metal into a symbol of human progress. By the end of his life, Caldwell had received 12 patents and seen his design used in over 200,000 aircraft across 40 countries. In Frank Caldwell's work, his constant speed propeller was now a lesson, proof that a small idea could change everything. Air Force reports showed that Caldwell's invention had improved the average fighter speed by 80 to 100 miles per hour during World War II. That single change gave the Allies an edge that no one expected. It made planes climb faster, fly farther, and use less fuel. In war, that meant the difference between life and death. Decades later, pilots still talked about it. One old mechanic said, "Without that prop, half our planes wouldn't have made it home. It was simple, but it worked like magic." Caldwell lived to see how his impossible idea became the small. To many, that meant his life's work was about to become useless. At first, he felt the same fear that so many inventors face, that the world had moved past them. One engineer remembered, Caldwell didn't talk much, but you could see it in his eyes. The jets were coming fast. But instead of giving up, Caldwell adapted. He worked on new ways to make propeller-driven planes even faster for transport and training. His design was still vital for many aircraft, especially cargo planes and naval aircraft that couldn't rely on early jets yet. By 1946, more than 300,000 constant-speed propellers had been built worldwide. They powered airliners, cargo planes, and even bush planes flying supplies into places without proper runways. The same technology that had carried war now carried peace. Caldwell was finally honored for his work. In 1946, he received the Collier Trophy, one of America's top aviation awards. The citation read, "For the invention of the hydromatic constant-speed propeller, a device that..." But what mattered most to him was the legacy of problem-solving, the belief that no idea was truly impossible. The constant-speed propeller became more than a machine. It became a bridge between slow and fast, between war and peace, between human limits and human imagination. As one pilot said years later, "We learned that power doesn't always come from more engines or bigger bombs. Sometimes it comes from a mind that refuses to quit." They had once laughed at the idea. They had called it too complex, too risky, and impossible. But in the end, Frank Caldwell's impossible propeller made American fighters 100 miles per hour faster and changed aviation forever. Because sometimes the smallest piece of a plane carries the biggest piece of history.